Hi there and welcome to InfoWorld. Today this video is about the 10 best fighter jets. So sit back and enjoy. Let's begin. This top 10 analysis is based on the combined score of stealthiness, armament, speed, range, maneuverability, and technology. We also considered pilot opinion on capabilities of various warplanes during dogfight training. All of these aircraft mentioned here are incredibly powerful and devastating. However, none of them have seen combat against each other during military operations yet. Top of the list is the F-22 Raptor. The Lockheed Martin F-22 Raptor is an American single-seat, twin-engine, all-weather stealth tactical fighter aircraft developed for the United States Air Force. The F-22's thrust and aerodynamics enable regular combat speeds of Mach 1.5 at 50 feet, thus providing 50% greater employment range for air-to-air missiles. The aircraft's dual Pratt & Whitney F119 augmented turbofan engines are closely spaced and incorporate pitch-axis thrust vectoring nozzles with a range of plus/minus 20 degrees. Maximum speed without external stores is approximately Mach 1.8 at military power, and greater than Mach 2 with afterburners. The primary air-to-air missiles are the AIM-120 AMRAAM and the AIM-9 Sidewinder, with planned integration of the AIM-260 JATM. The F-22's stealth contouring and radar-absorbent materials are chiefly effective against high-frequency radars, usually found on other aircraft. The effects of Rayleigh scattering and resonance mean that low-frequency radars such as weather radars and early warning radars are more likely to detect the F-22 due to its physical size. However, such radars are also conspicuous, susceptible to clutter. By fiscal year 2015, the cost per flight hour was $59,116. It is capable of flying at trimmed alpha of over 6 DITIC while maintaining roll control and performing maneuvers such as the Herbst maneuver and Pugachev's Cobra. Next is Lockheed Martin F-35. The Lockheed Martin F-35 Lightning II is an American family of VTOL single-seat, single-engine, all-weather stealth multi-role combat aircraft. It is also able to provide electronic warfare and intelligence, surveillance, and reconnaissance capabilities. The F-35 has a wingtail configuration with 2 vertical stabilizers canted for stealth. Flight control surfaces include leading-edge flaps, flaperons, rudders, and all moving horizontal. Leading-edge root extensions also run forwards to the inlets. It has a relatively short 35 feet wingspan. All variants have a top speed of Mach 1.6, attainable with full internal payload. The powerful F-135 engine gives good subsonic acceleration and energy with supersonic dash and afterburner. Due to the HMDS's vibration, jitter, night vision, and sensor display problems during development, Lockheed Martin and Elbit issued a draft specification in 2011 for an alternative HMDS based on the a VS9 night vision goggles, as backup, with B systems chosen later that year. It has 2 outboard weapon stations, each can carry ordnance up to 500 pounds, while the 2 inboard stations carry air-to-air missiles. The F-35A is armed with a 25mm GAU-22 divided by a rotary cannon mounted internally near the left wing root with 182 rounds carried. The single-engine aircraft is powered by the Pratt & Whitney F-135 low-bypass augmented turbofan with rated thrust of 191 kilonewtons. Derived from the Pratt & Whitney F-119 used by the F-22, the F-135 has a larger fan and higher bypass ratio to increase subsonic thrust and fuel efficiency. Next is the Sukhoi Su-57. The Sukhoi Su-57 is a twin-engine stealth multi-role fighter aircraft developed by Sukhoi. In 1979, the Soviet Union outlined a need for next-generation fighter aircraft intended to enter service in the 1990s. The Su-57 is a 5th-generation multi-role fighter aircraft incorporating thrust vectoring and large leading-edge root extensions that shift the aerodynamic center forward. The majority of the structural materials are alloys with 44.5% aluminum alloys and 18.6% titanium alloys. The high degree of static instability in both pitch and yaw, advanced KSU-50 flight control system, and canted thrust vectoring nozzles make the Su-57 departure resistant and highly maneuverable in all axes and enables the aircraft to perform very high angles of attack maneuvers such as the Pugachev's Cobra and the Bell maneuver, along with doing flat rotations with little altitude loss. Combined with a high fuel load, the fighter has a supersonic range of over 1,500 km. The shaping of the aft fuselage is less optimized for radar stealth. The Su-57 is powered by a pair of NPO Lyulka Saturn Izdala I-117, or AL-41F1, augmented turbofans. The engine is a highly improved and uprated variant of the AL-31 and produces 9 tons of dry thrust, 14.5 tons of thrust in afterburner, and 15 tons of thrust in special emergency power. The aircraft employs thrust vector control where the vectoring nozzle's rotational axes are each canted at an angle, similar to the nozzle arrangement first employed on the Su-30 MKI and also used on Su-35S. The Su-57 has two tandem main internal weapon bays, each approximately 4.4 meters long and 0.9 meters wide, and two side weapon bays with triangular section fairings under the fuselage near the wing root. For striking surface targets, the aircraft can carry the 250 kg KAB-250 or 500 kg KAB-500 precision-guided bombs in its main bays. Internal weapons also include the KH-38M air-to-ground missile, KH-35U anti-ship missile, KH-58S HK anti-radiation missile, and KH-59 Mk2 cruise missile. The aircraft has a 9A1 to 4071 Kelvin 30mm autocannon with 150 cartridges mounted internally near the right LEVCON root. The weapon has an effective range of 800 meters against aerial targets and 1,800 meters against surface targets. The Su-57 has a glass cockpit with no analog gauges. Information is displayed on two 38 cm main multifunctional LCD displays. The aircraft uses the NPP Zvezda K36D5 ejection seat and the SOZHE-50 life support system, which comprises the anti-G and oxygen generating system. Coming up is the Chengdu J-20. The Chengdu J-20, also known as Mighty Dragon, is a twin-jet all-weather stealth fighter aircraft developed by China's Chengdu Aerospace Corporation. The J-20 has a long and blended fuselage, with a chiseled nose section and a frameless canopy. All moving canard surfaces with pronounced dihedral are placed behind the intakes, followed by leading-edge extensions merging into the delta wing with forward-swept trailing edges. The aft section has twin outward canted all-moving fins, short but deep ventral strakes. That J-20 seconds use Type 1475 active electronically scanned array radar, with 1856 transmit or receive modules. The aircraft features a fully digital glass cockpit with one primary large color liquid crystal display touchscreen, three smaller auxiliary displays, and a wide-angle holographic heads-up display. The main weapon bay is capable of housing both long-range air-to-air missiles and precision-guided munitions, while the two smaller lateral weapon bays behind the air inlets are intended for short-range AAMs. The fighter typically carries weapons internally. The wings include four hardpoints for auxiliary fuel tanks to extend the ferrying range. The intended power plant is the Xi'an WS-15, with a thrust of 180 kN, which is required for supercruise. Analysts noted that the J-20's airframe employs a holistic approach to reduce its radar cross-section, uniquely combining canard wings with leading-edge root extensions. Coming up next is Boeing F/A-18. The Boeing F/A-18 Fahrenheit Super Hornet is a twin-engine, carrier-capable, multi-role fighter aircraft variant based on the McDonnell Douglas F/A-18 Hornet. The Super Hornet has an internal 20mm M61 rotary cannon, and can carry air-to-air missiles and air-to-surface weapons. Additional fuel can be carried in up to 5 external fuel tanks, and the aircraft can be configured as an airborne tanker by adding an external air-to-air refueling system. The Super Hornet is largely a new aircraft at about 20% larger, heavier empty weight, and heavier maximum weight than the original Hornet. The General Electric F414 engine, developed from the Hornet's F404, has 35% additional thrust over most of the aircraft's flight envelope. Block 2 aircraft were fitted with the AN, a PG-79 AESA radar, capable of executing simultaneous air-to-air and air-to-ground attacks, and providing higher quality high-resolution ground mapping at long standoff ranges. The AESA radar can also detect smaller targets, such as inbound missiles, and can track air targets beyond the range of the aircraft's air-to-air missiles. The Eurofighter Typhoon is a European multinational twin-engine, canard delta-wing, multi-role fighter. The Typhoon features lightweight construction. Although not designated a stealth fighter, measures were taken to reduce the Typhoon's radar cross-section. The Typhoon features a glass cockpit without any conventional instruments. It incorporates 3 full-color multifunction head-down displays, a wide-angle head-up display with forward-looking infrared voice, and hands-on throttle and stick, a helmet-mounted symbology system, a MIDS, a manual data entry facility located on the left glare shield, and a fully integrated aircraft warning system with a dedicated warnings panel. In the event of pilot disorientation, the flight control system allows for rapid and automatic recovery by the simple press of a button. The aircraft also has an automatic low-speed recovery system which prevents it from departing from controlled flight at very low speeds and high angle of attack. DVII is a system which provides the pilot with an additional natural mode of command and control over approximately 26 non-critical cockpit functions to reduce pilot workload, improve aircraft safety, and expand mission capabilities. The Raptor is a mechanical multi-mode pulse Doppler radar designed for the Eurofighter Typhoon. The Eurofighter operates automatic emission controls to reduce the electromagnetic emissions of the current captor mechanically scanned radar. The Eurofighter Typhoon is fitted with two Eurojet EJ200 engines, each capable of providing up to 60 kN of dry thrust and greater than 90 kN with afterburners. Using the war setting, dry thrust increases by 15% to 69 kN per engine and afterburners by 5% to 95 kN per engine, and for a few seconds, up to 102 kN thrust without damaging the engine. The Typhoon also carries a specially developed variant of the Mosser BK-27 27mm cannon that was developed originally for the Panavia Tornado. This has a single-barrel, electrically fired, gas-operated revolver cannon with a new linkless feed system. It can carry GPS bombs such as GBU-10 Paveway-2, the Storm Shadow and KEPD-350 cruise missiles. German aircraft can carry 4 GBU-48 1,000 pounds bombs. Up next is Dassault Rafale. The Dassault Rafale is a French twin-engine, canard delta-wing, multi-role fighter aircraft designed and built by Dassault Aviation. The aircraft is capable of withstanding -3.6 G to 9 G, and a maximum of 11 G can be reached in case of emergency. Rafale is an aerodynamically unstable aircraft and uses digital fly-by-wire flight controls to artificially enforce and maintain stability. The aircraft's canards also act to reduce the minimum landing speed to 115 knots. The Rafale M features a greatly reinforced undercarriage to cope with the additional stresses of naval landings, an arrestor hook, and jump strut nosewheel, which only extends during short takeoffs, including catapult launches. Although not a full-aspect stealth aircraft, the cost of which was viewed as unacceptably excessive, the Rafale was designed for a reduced radar cross-section and infrared signature. The Rafale's glass cockpit was designed around the principle of data fusion. A central computer selects and prioritizes information to display to pilots for simpler command and control. The primary flight controls are arranged in a hands-on throttle and stick-compatible configuration, with a right-handed side stick controller and a left-handed throttle. The cockpit features a wide-angle holographic head-up display system, two head-down flat panel color multi-function displays, as well as a central collimated display. In the area of life support, the Rafale is fitted with a Martin Baker Mark 16 Fahrenheit 00 ejection seat, capable of operation at 0 speed and 0 altitude. The Rafale core avionics systems employ an integrated modular avionics, called MDPU. Precision ground attacks typically using Scalp EG cruise missiles and AASM Hammer air-to-surface missiles. In addition, anti-shipping missions could be carried out using the AM-39 Exocet sea skimming missile. The Rafale is fitted with two Snecma M88 engines, each capable of providing up to 50 kilonewtons of dry thrust and 75 kilonewton with afterburners. Up next is Sukhoi Su-35. They are single-seat, twin-engine, super-maneuverable aircraft, designed by the Sukhoi Design Bureau and built by Sukhoi. The Su-35 multi-role fighter is a significantly developed version of the Su-27. It is being offered for export as a replacement for the Su-27 and MiG-29 fighters. In 2012 it has been adopted by the Russian Air Force. Developers refer the Su-35 as 4++ generation fighter. It is a very fast and highly maneuverable fighter with very long range, high altitude capability, and heavy armament. It poses a great threat to Western 4+ generation fighters. The Su-35 is primarily an air superiority fighter. However, it has secondary air-to-ground capability. This aircraft can carry enormous amount of weapons. It has 12 wing and fuselage hardpoints and can carry ordnance with a maximum weight of up to 8 kilograms. Its large and powerful engines give it ability to supercruise for a long time. Also, its engines allow to reach supersonic speeds without using an afterburner. Engines have a three-dimensional thrust vectoring and make this aircraft very maneuverable. Coming up is McDonnell Douglas F-15 Eagle. The McDonnell Douglas F-15 Eagle is an American twin-engine, all-weather tactical fighter aircraft designed by McDonnell Douglas. The empennage is of metal and composite construction, with twin aluminum, composite material honeycomb structure vertical stabilizers with boron composite skin, resulting in an exceptionally thin tailplane and rudders. Composite horizontal all-moving tails outboard of the vertical stabilizers move independently to provide roll control in some flight maneuvers. It is powered by two Pratt & Whitney F100 axial compressor turbofan engines with afterburners, mounted side-by-side in the fuselage, and fed by rectangular inlets with variable intake ramps. A multi-mission avionics system includes a head-up display, advanced radar, ASN 109 inertial guidance system, flight instruments, ultra-high frequency communications, and tactical air navigation system and instrument landing system receivers. It also has an internally mounted, tactical electronic warfare system, identification friend or foe system, an electronic countermeasures suite, and a central digital computer. The Eagle can be armed with combinations of 4 different air-to-air weapons, AIM-7 FM Sparrow missiles or AIM-120 AMRAAM advanced medium-range air-to-air missiles on its lower fuselage corners. Low-drag conformal fuel tanks can be attached with these jets holding 2,840 liters of fuel. Last on the list is Mikoyan MiG-31. The Mikoyan MiG-31 is a supersonic interceptor aircraft that was developed for use by the Soviet Air Forces. The MiG-31 was among the first aircraft with a phased-array radar, and one of 2 aircraft in the world capable of independently firing long-range air-to-air missiles. The aircraft is a 2-seater with the rear seat occupant controlling the radar. Although cockpit controls are duplicated across cockpit, the aircraft is a 2-seater with the rear seat occupant controlling the radar. Although cockpit controls are duplicated across cockpits, the MiG-31's main armament is 4 R-33 air-to-air missiles carried under the belly, 1 GSH-623 23mm cannon with 260 rounds and many more armaments. That's all for this video. See you soon. Goodbye.